Well, this one looks especially fun. So the whole thing is one big fraction, and then within the numerator there's fractions, within the denominator there's fractions. That's called compound or complex fractions. I just call it fun. Well, let's see. What we need to do is first simplify the numerator, then simplify the denominator, and then use the rule that says to divide a fraction, one fraction by another, you invert and multiply the second one. So let's simplify the numerator first. So you've got 3 4/5 minus 1 9/10. Well, you can subtract the whole number from the whole number, and then subtract the fraction from the fraction, but there's tricky situations when this one is smaller than this one, then it gives you something that's negative, then you have to go back over to the whole number and borrow. To get rid of that problem and not have to deal with all of that, instead of using a mixed number, change this to an improper fraction. So multiply this direction, 5 times 3 is 15, add that to 4 is 19. So we have 19/5. Change this one, multiply, this is going to be 10, and then add it to 9 is 19. And then that one's tenths. For a 5 and a 10, the least common denominator is 10, so this one needs to be multiplied by a 2 on the top and the bottom. So 2 times 19 is 38, so we have 38 tenths minus 19 tenths. Well, that's going to be tenths, and 38 minus 19 is 19. So I did this work on scratch paper, and then I'm going to go over here and say, okay, what we really have is one big fraction. I just simplified the top. The top is 19 tenths. Okay, now for the denominator. So that's 6 5/6 minus 2 3/4. Again, convert them to be improper fractions. So multiplying this direction will be 36 plus 5 is 41/6. Multiply here is going to be 8. 8 and 3 is 11. So it's good to be able to eventually just be able to look at those and find out, well, what is the least common denominator? It's going to be a 12. The way that I do it is, as sort of a shortcut, I just think about the multiples of 4. So 4, 8 times 3 is 12, and 16, etc. And for 6, it's 6, 12. Oh, stop. There it is right there. They both can be turned into a 12. So with this one, multiply the top and the bottom by a 3. With this one, multiply the top and the bottom by a 2. So for the one on the left, we're going to have 84/12 minus, this will be 33/12. Okay, so we just need 84 minus 33. That's going to be a 51. So 51/12. So I simplified this, it's going to be 51/12. So you leave the first fraction alone, 19 tenths, then invert and multiply. And then it's time to reduce. So this 19 is a prime number. Can't be broken down any smaller. So unless you could have a 19 somehow divide into a 51, which is not going to work, the 19 is not going to be reduced. The 19 is going to stay there. What can be reduced is these two are even numbers, so you could divide them by 2. Divide by 2 is a 6. Divide by 2 is a 5. Let's see. What about that 51? Well, 51, that can be divided by 3. There's this little trick for divisible by 3. You just take the two numbers, the 5 and the 1, add them up, you get a 6. If the number 6 can be divided by 3, then the number 51 can be divided by 3. So, it's actually 3 times 17. And I needed that 3 because the 3 can divide into the 6, leaving a 2. So let's see. My final answer here is going to be, on the top there is a 19 and a 2. That is 38. On the bottom, everything canceled except for this 5 and this 17. So let's see, a 5 times 7 is 35, and a 5 times the 10 part is a 50. So a 50 and a 35 is 85. On to the next one. So we could go ahead and work with these mixed numbers, or like I did here, we could change these to improper fractions, which is what I think I'm going to do. So this one, multiply, that's a 4, plus 1 is 5 halves, plus, multiplying here would be 12 plus 1 is 13 fourths. This, hey, wait a second, that's the same thing as that over there. It's going to be 5 halves again, minus a 3/4. Now because of the parentheses, we still need to simplify everything in the parentheses here, then simplify everything in the parentheses here, and then in order to get rid of the parentheses, multiply. So over here, we need a common denominator, which is a 4. This one can be changed into a 4 if we multiply the top and the bottom by 2. So that's going to be parentheses 10 fourths plus 13 fourths. The same is true over here, multiply by 2 and multiply by 2. So this will be 10 fourths again, but then minus 3 fourths. Combine these, that's going to be, let's see, a 13 and a 10 is 23 fourths. These are subtracting, so 10 minus 3 is 7, so this one is 7 fourths. And I still need the parentheses all the way up until this point because this whole time the parentheses has meant you're going to have to multiply these two. So looking at this, I look, can a 4 divide into a 23? No. That's an odd number, that's not going to work. The same thing here, 4 won't divide into 7. So that means it's not going to reduce at all. That means you're just going to have to multiply on the top. I'll do the easy part. Multiply on the bottom, 4 times 4 is 16. And then for 23 times 7, get some scratch paper. 23 times 7. So 7 times 3 is 21. Then 7 times 2, that's 14, and then 15, 16. So it's a 161. And I know that this cannot be reduced because that's what I was checking over here. Will 4 divide into 23? No. Will 4 divide into 7? No. So it can't be reduced. Exponents. So you look inside the parentheses, see if it could be reduced. Simplified? Nope. Then square it. So squaring means times itself. So 9 times 9 is 81. Because it's got the parentheses, it means everything inside the parentheses gets squared. So this means it's 2 times 2, which is 4. And then just recopy the other two numbers. Next, I could combine these two. they already have a common denominator of 4, so that means it's going to be quarters. And then I just need to figure out 81 minus 7. Well, the way I do it is I go 81, take off 1, and it's 80. So now I only have to subtract 6 because I already used up 1. And 80 minus 6 would be 74. All right, then we need to add 2 and have it be reduced. So let's see. I could say, first of all, this is the same thing as saying it's over 1. Then the common denominator would be 4. Multiply the top and the bottom by 4. So then we've got the fraction 74 fourths plus 8 fourths. And a 74 plus an 8, that's going to be 82 fourths. Well, those two numbers are even, so this definitely can be reduced. I'm not sure if a 4 will divide into an 82 right now. So what I can do is say, well, I know a 2 can. No, I don't really know a 2 can. That's a type of bird. I know that a 2 is able to. So divide by 2, it leaves a 2 down here. Divide by 2, well, if you divide an 8 by 2, that's a 4. If you divide a 2 by 2, that's a 1. So it leaves 41 over 2. Since 41 is odd, the 2 is not going to divide into it, so this one is done. Let's see over here. First of all, it's saying that a negative 2/3 needs to be squared. So if you square the negative, a negative times a negative is positive. So this is going to become positive. Square the 2 is 4. Square the 3 is 9. And it's positive. But then you have to recopy everything else in the problem, including this subtraction sign. So I'm done with the parentheses because the parentheses go together with the square. I'm done with that. This negative is gone because when you square a negative, it's positive. And then just recopy this and everything else. Well, we've got fractions again. The common denominator for these two is going to be a 9. So I need to change all the denominators into a 9. So this one multiply by 3 on the top and the bottom. This one multiply by 9 on the top and the bottom. So 9 times 6 is 54. So the first one is 54 ninths. The middle one, 2 times 3, is 6 ninths minus 4 ninths. So it's going to be ninths. Then let's see. A 54 plus a 6 is 60. And then 60 minus 4 is 56. Will a 9 divide into 56? Well, let's see. A 9 is made of a 3 and a 3. So an easier question is will a 3 divide into a 56? But a 5 and a 6, if you add them, makes an 11. Since an 11 cannot be divisible by 3, 56 cannot be divisible by 3. So it can't be reduced. We're done.